Alright, so here's how Advent of Code 2021 Day 21 works. So in part 1, we're given a die which has 100 sides and 2 pawns, so there's 2 players in this game, and uh, the die is deterministic, so on the first roll it rolls a 1, then it rolls a 2, and so on. And then you have a starting position for your piece and a starting position for the opponent's piece in this board, which has 10 spots. So when it's your turn, you roll the die 3 times, so it gets 3 consecutive numbers, and whatever the total of those is, you move forward that many spaces on the board, and that wraps back around to the beginning. So, as shown in the example, we start at position 4, so if you roll 1, 2, 3, that sums to 6. So, from your position of 4, you move to position 10, so your total score is 10. That's where you ended up. And then on your next turn, if you roll 7, 8, and 9, then it adds up to 24. So it's like modulus, so 10 plus 24, you would end up at position 4. So you add 4 to 10, so 14. So it's not too bad for part 1. It's kind of a lot of instructions to comprehend. And then in part 2, things are a little bit more interesting. So you have a quantum die, so it makes a whole different universe every time that you roll it. So when you roll 3 times on your turn, then you're basically making a lot of different universes. But some of them might end up at the same spot, but you got there a different way, so that counts as different. You say how many universes the player that wins and more wins in. So the way I solved this, you can use dynamic programming. So I ended up making a 3-dimensional array, but default dict, it's the same thing in this case, or used similarly. So you have to keep track of, let's say I'm player 1 and I win on turn 3, then I beat all the other situations where the other player won going up until that time. So like however he played on his first turn and his second turn, those are unique ways that I won. So it's like I beat him however he played on his first and second turn one way, and I beat him he played on his first and second turn a different way. As long as I use whatever sequence of moves, then I win. So you have to keep track on each turn. First, it's the turn number is what I have, and then the score that you achieved. But then you have to know how you got to that spot, because remember you're moving your token along. So when you do that, then it's like, well, was my token at position 3? Because if I was and I just rolled a total of 3, then I should move it to position 6. If I was at, say, position 7, and I rolled a 3, then I should be adding 10 to my score, so you have to keep track of how you got there. So, yeah, the DP here, the turn number, and then the score that you got, but then it's whatever position you were just at, and then how many ways you were able to get to that position. So it's bottom up dynamic programming here. So you can kind of arbitrarily cap this number. You can stop it after like 10 or so, maybe 12. But that's like how many turns it takes before somebody wins, because somebody wins when they reach a score of 21, not 1,000 like in part 1. So for each score in this turn, like, then if that score is already greater than 21, then you shouldn't do anything with it, like the player's already won. Otherwise, you want to look at each previous position that they were at to get here, and then how many times they're able to get to that position on the last turn with this score in the end. And so for each roll that you can get in the number of ways you can roll 3 die. So I use distinct permutations. This is from more ITER tools. So as it says here, It's equivalent to this, but doesn't generate the duplicate, so that's slightly more efficient. So with that, it's basically a curve where, here I can print this out using my printd function to print a dictionary. If we run this in this part here, then there's one way to roll 3 dice and end up with a total of 3. Then there's 3 ways to get a total of 4, and so on, 6, and then 7. So for each of those ways, you basically have to build up and say, the next position I'm going to be at is whatever position I was at to get here, plus whatever I just rolled. So if I'm at position 7, and then I roll a 3, then I end up in position 10. But if you're greater than 10, remember it's supposed to wrap back around. And the new score that you have, it's whatever your score was before. Then add that to your new position. And so basically in the next state, so it's like the turn after my current one, then I have this new score, and then whatever position I just found out that I could get or end up at and have that score. You want to add on the number of times that you've seen that previous position. Like if it's turn, let's say 5, I was able to end up with a score of 12. Actually, that's a little low. Well, so we'll say it's turn 4 and you end up with a score of 12. Then you could have done that a lot of different ways, but all you care about currently is if you're at score of 12, then let's say I was at position 5 and I was able to get here. You want to know the number of ways that you ended up at position 5. And then the number of ways that you can roll the die to end up at the next spot. So that's where it comes back to this. Like I can roll the die 3 times and there's 6 ways to end up with a total of 5. So that's why we have to consider it that way. And you basically have to keep track of, well, we have it up here, whatever the turn number is, and then the way that some scores were achieved. You technically don't need this other dictionary, but it saves later from having to sum up a 3D dictionary or 3D array. So you just want to track how many times that you've seen on this turn, how many times have I seen this score, basically. And so we return that whole big, or I guess it's not that big of a table at the end. And so you have to calculate. Yeah, it's a lot of probability in this question. We save those for player 1 and player 2. And so the total wins for each player. So for player 1, you have to track, here, I'll expand this. So if we're currently on turn 3, because that's the first turn that anybody can actually win, like it's impossible to win before that. At least with my input. Yeah, I guess, yeah, it's impossible in general, because even if you got 9 and 10, or I guess 10 and 9 as your scores, then that's only 19 enough to win. Yeah, so we're currently looking at turn 3, then it's a winning score if it's above 21, but caps out at 30, so we say to 31, exclusive upper bound. If I was able to win on turn 3, then that just means that I beat the other player every way that he played on turn 1 and turn 2. Or rather, the previous turn, because we're already building up when we do the DP. So you only have to look at the turn right before this one. And you'll notice it's slightly different for players 1 and 2, because player 1 goes first. And so if they win, then player 2 doesn't even get to go that turn. So that's why it's -1. because player 2 hasn't played yet on this turn. Any score that player 2 had that was less than 21, then I beat all of them. My winning score. Yeah, so slightly different for player 2. Except this time you don't do the -1 here because player 2 always went after player 1. So if it's turn 3 and player 2 won, that means that player 1 has already gone on turn 3. So we have to calculate, oh, whatever he did, he didn't win. So we add those up for the total wins. And then it's just whoever won, you have to say how much or how many universes they won in. And it's whoever won in more universes. So that is Advent of Code Day 21. Thanks for watching.